Hello everyone and welcome back to the 12 Cylon Challenge. We are a little late with this episode, but that's okay. Sometimes you have ups, sometimes you have downs, but progress marches inexorably forward. So with this last batch of work, there have been victories and there have been losses. The robot is now portable, but not that portable. The remote control now works, but not quite how I want it to. And we've got some new parts. There's actually nothing wrong on that count, so net positive progress! Also, I'm trying something a little new with the camera placement to see if that sorts out my lighting problem. Let me know if you think that's working or not. So let's start this episode off by going from the less significant news to the more significant news. To begin with, the remote. Originally, I was going to use this to control the robot. This is an infrared remote that would control it the same way that you would, say, change the channel on your television. The problem is that means you would need to be in the vicinity of the robot, which is completely meaningless in the context of telepresence. I don't know if you could hear that, but there was a ringing noise in every video that I tried to record, so I switched over to my phone camera. Hopefully that fixes it. So where was I? Telepresence. If you want to be telepresent, if you want to teleport somewhere else, you don't want to teleport to the next room over. You want to be somewhere on the other side of the world. So it makes no sense to have an infrared remote. So I ordered this. This is a Bluetooth remote that connects directly to your phone. So the way we're viewing what the robot is viewing is through a VR application that runs on a web page, and you see it through the cardboard headset. This connects to your phone and thus can control the robot via the same web page through which you are viewing the robot's perspective. And this just strikes me as a much better solution, because while right now the Pi server that controls the robot is only accessible inside the house, I would just need to make some configurations and give it a web address, and potentially any of you watching this video would be able to control it from whatever country you're in. Next order of business is the powered USB hub. You'll remember that the last one perished in an unfortunate accident in last episode. You mean the one you blew up in your living room? So I ordered a new hub to replace the old one, connected a dongle to it, hooked it up to the Pi, and everything worked exactly as it should. It's amazing what you can do when you use appropriate quantities of electricity. So that's all fine and good, but now we need to disconnect the Pi and the hub from the wall and give them portable power supplies. And this is a problematic proposition. The last time I put a Pi in a robot, I powered it with 6 alkaline batteries, which are kind of heavy. But remember, this time we have the hub, so we need another 6, and we already have 4 for the motors, which I'll show you in a minute. Now this all adds up and makes your robot quite heavy, and the batteries don't even last that long, which makes no sense whatsoever. So your Raspberry Pi is a computer. Your phone is also a computer, and this one lasts for almost the entire day, if not for several hours. And I know there are different kinds of batteries, so I decided to do some reading on what kind your phone uses to see if I could maybe get that kind for my robot. Article in the description, by the way. I also read about some of the different ways that people power their Pi-controlled robots. One of them is lithium polymer batteries, which are commonly found in mobile phone power banks. These power banks are small, they store a fair bit of charge, they are rechargeable, and they are so freaking obvious. How did I not think of this before? The Raspberry Pi literally has a micro USB port, exactly the same as a smartphone. How was this not the first thing that I came up with? Anyways, I know now, and I had a couple lying around, so I didn't need to spend any extra money on them. So, portability problem solved. Except for the part where it's not solved. The Raspberry Pi uses a micro USB port, but the hub uses a DC port. But luckily, I thought ahead. I noticed this in the hub, so I got a DC to USB cable. The USB end goes in the hub, in the power bank. The DC end goes in the hub. Except that it doesn't go in the hub. It turns out there are different types of DC plugs out there. I've put a graphic on the screen for you guys, and if you look at these, the one that I ordered is actually none of these. My one is 4.8 by 1.7. The one that it's supposed to be is the 5.5 by the 2.5. This is incredibly inconvenient. Sudden lighting change. Now, a new cable would cost $5 plus $10 shipping. In addition to the cable that I already have, that's a total of $30, which, call me crazy, I think is a little too much for a cable. Especially when I have everything that I need right here. So the powered hub that I bought came with 2 adapters, one for Australia and one for the UK. The UK one I don't fits perfectly into the hub. So now we have the DC side of the cable, but not the USB side. However, throughout my technological escapades, I've acquired a lot of micro USB cables, which have micro USB on one end and regular USB on the other end. So now we have the USB side of the cable, but not the DC side. So I'm sure you can see where I'm going with this. Just connect the two up. Electricity is just basically your red wire and your black wire, VCC and ground, so you just snip the two cables open, connect them together, tape them up, and it should work fine. And I still have the old hub. It's not completely fried, it still lights up, so I can use that for testing to make sure that nothing goes wrong and nothing important breaks. So it can't be that hard. It's the worst that could happen. Fiery, fiery death! What else is new? What else is new? We have motors now. The Pi can control motors. So there's a nice little tutorial on how to do that in the description. The only thing though is that the breadboard that I have is different from the one in the tutorial, so I had to be more creative with my wiring. But to do so, I had to read about how breadboards work. So there's a really good article on that, also in the description. But the point is, the motors work now. I should mention that this is another place where I've made changes to the architecture. Originally, I was going to have an Arduino control the motors, and then have the Arduino communicate with the Pi via a cable. But as it turns out, the Pi has what are called GPIO pins, which can control the motors directly. So I just decided to take out the middleman, and that makes things much simpler. Thank you very much to my friend Khaled for letting me know about those pins, because that's something I didn't know about before. And actually, I want to give a really big shout out to my friend Khaled, because in addition to the GPIO thing, he's been helping me sort out the remote control code for this robot. So the idea is I want to control the robot from the web page. And the way you do that is using JavaScript. You have some code that responds to button presses or remote control movements in my case, and then that executes scripts on the server. But JavaScript doesn't seem to want to let me do that, and from what I can ascertain from various web sources, it seems to be because executing code on the server via the browser is a security risk, and JavaScript doesn't want to let you do that. You can do it, but it's not particularly easy. So after I gave up on doing it the JavaScript way, I decided to write some Python code that would just use your standard console and let you communicate directly with the server without JavaScript or a web page as an intermediary. And this works fine, but the problem is that that means you need to have a computer open while you're running the VR app in your headset. And that's just not a nice way of doing things. So Khaled's idea was to open up a socket on the server, and for the non-techies out there, just think of that as a communication channel. So you open up the socket and you have some code running on the server side, which is the Pi, and you have some code running on the client side, which is either a computer or a web app, potentially, and then they communicate via the socket, and the problem is solved. So Khaled is a much more skilled developer than I am, and he knows a lot more about socket programming, namely he knows how to do it. So he drafted up some code to run on the server side, and we collaborated a bit, and we worked on getting it running on the robot. And I actually have a video for you of the moment when we finally got it working. Test number 6. Running from the server. Running server code. It's not giving me warnings, which you'd think is a good thing, but it's probably a bad thing. Okay, running client-side code. Pressing, moving forward. Moving forward works. Moving backwards works. Oh, la, 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 la. Stuff is happening. Bro, stuff is happening. How do we stop at B? Huh? It works. Okay, successful. Let's do it again just for fun. Of course, I'm sure you also want to see the robot moving on the ground since we have all the pieces together, so I have a clip of that for you as well. Test 31. Movement via remote control. Please don't break. Forward. Backward. Spin to the right. They're flipped to the left, which is actually the right. Good enough. Yeah, and that's where we are right now. And you know, I think given all the help that Khaled's been giving me, he's sort of been giving me little tips all the way through. very consistently, and given that I think he's going to continue to do so as I go through this project, I think that entitles him to his very own bobblehead.
I will cut you.
Whoa! Whoa!
I swear, I will cut you.
Are those scissors?
Listen, mate, I'm sure your friend is a very nice guy, but this is my channel, and I will be the only bobblehead here. Do we understand each other?
No, you know what? No, this isn't your channel. When was the last time you even helped me? All you do around here is you make snarky, sarcastic remarks, and you don't help at all. So you know what? I think it's time for you to take a bit of a break, Matt.
You stay back. I have a weapon. I have a weapon. Oi! Oi! No!
No, you are going to get a timeout, and you are going to stay there until you're ready to stop making sarcastic remarks and start helping me again. And that's the end of that. I am sorry you guys had to see that. Anyways, without further ado, allow me to introduce you to my friend, Khaled.
This is a very awkward way to be introduced.
Yeah, sorry about that. Yeah, and that about covers it for this episode. Next episode, I'll be looking at the putting together that cable so we can have a fully untethered demo, hopefully, playing around with servos, and I'll see what I can do about the whole remote control situation. But until then, thank you guys again for watching, and I will see you next time.